Welcome back to Space Exploration Technology, the channel where we dive deep into the mysteries of the universe. Today's epic journey takes us into one of the most dramatic cosmic scenarios humanity has ever imagined, an asteroid hitting Earth. This is more than just a Hollywood movie plot, it's a very real scientific possibility, one that astronomers, space agencies, and planetary defense experts have been studying for decades. When people hear the phrase asteroid hitting Earth, they often imagine fiery explosions, mass extinctions, and the end of civilization. But what does science really say about the threat? How do we define an asteroid? Where do these giant space rocks come from? What are they made of? And what would actually happen if one of them collided with our planet? Let's start with the basics, the asteroid definition. An asteroid is a small rocky body orbiting the Sun. Unlike planets, asteroids are much smaller and irregular in shape. Most of them are leftovers from the early formation of the solar system, about 4.6 billion years ago. They never coalesced into a planet, so they remain scattered fragments. The largest collection of these objects is found in the asteroid belt, a vast region of space located between Mars and Jupiter. The asteroid belt contains millions of rocky bodies of all sizes, from tiny pebbles to objects hundreds of miles wide. Some famous asteroid names include Ceres, the largest in the belt, Vesta, known for its bright surface, and Eros, which was visited by NASA's near Shoemaker spacecraft. Now, let's explore what are asteroids made of. Most asteroids fall into three broad categories. C-type asteroids, or carbonaceous types, are rich in carbon and water-bearing minerals. These are some of the oldest objects in the solar system. S-type asteroids are silicate-rich, made of rocky minerals and some metallic content. M-type asteroids are metallic, often composed primarily of nickel and iron. Understanding what asteroids are made of is critical because the material composition would affect the impact scenario. A metallic asteroid hitting Earth, for example, would penetrate the atmosphere more effectively and deliver far more destructive energy than a fragile, carbon-rich one that might break apart before impact. Let's talk about history because the past is our best guide to the future. There are many asteroid facts we've learned from geology and astronomy. One of the most famous events was 66 million years ago when a massive asteroid struck near what is now Kixalub, Mexico. That single asteroid hitting Earth caused the extinction of nearly 75% of species, including the dinosaurs. It released the energy equivalent of billions of nuclear bombs and changed the climate for decades. This is why scientists today track near-Earth objects so carefully. Even though the asteroid belt is far away, gravitational interactions with Jupiter or other planets can send asteroids on unstable orbits, turning them into Earth crossers. The odds of a large asteroid hitting Earth in our lifetime are small, but not zero. For smaller impacts, the odds are much higher. In fact, Earth is hit by tiny space rocks every single day. Most burn up harmlessly in the atmosphere as meteors, but every few decades, something larger tens of meters across can explode in the atmosphere with the force of a nuclear weapon. One modern example was the Chelyabinsk event in 2013. A 20-meter asteroid exploded over Russia, injuring more than 1,000 people with shattered glass from the shock wave that wasn't even considered large on the cosmic scale. Imagine if something 500 meters wide, about the size of a skyscraper, were to strike. That kind of asteroid hitting Earth could wipe out an entire region or even cause global climate disruption. Now let's dig deeper into the science. How do we even detect these potential threats? Astronomers use telescopes, radar imaging, and infrared surveys to map asteroid orbits. NASA's Planetary Defense Coordination Office and international partners keep constant watch. They maintain catalogs of known asteroid names, tracking their paths decades into the future. When astronomers calculate that a certain asteroid might come close, they flag it as a potentially hazardous asteroid. But here's an important set of asteroid facts. So far, none of the large asteroids we know of pose a direct collision threat within the next century. Still, there are many smaller ones we haven't discovered yet. NASA estimates that about 60% of the mid-sized near-Earth asteroids remain undetected. That is why new telescopes like the upcoming NEO Surveyor mission are designed to find them before it's too late. What if we actually discovered a massive asteroid hitting Earth was imminent? What would humanity do? Science fiction often shows nuclear missiles or giant laser cannons blasting the rock to pieces. But in reality, blowing up an asteroid could make the situation worse, turning one giant target into thousands of smaller fragments that still hit Earth. Instead, planetary defense experts prefer deflection strategies. One idea is the kinetic impactor, slamming a spacecraft into an asteroid to slightly change its trajectory. In 2022, NASA tested this concept with the DART mission, which successfully redirected the orbit of a small asteroid moonlet named Dimorphos. This was the first real-world test of asteroid deflection technology. Another option is the gravity tractor. Imagine a spacecraft hovering near an asteroid for years, using its own tiny gravitational pull to slowly tug the rock off course. There's also talk of using focused solar energy, attaching giant mirrors, or even spraying paint on the asteroid to change how it absorbs sunlight, gradually altering its path through what's called the Yarkovsky effect. No matter the method, the key is early detection. If we see a threatening asteroid hitting Earth decades before impact, we have a chance to push it out of harm's way. If we find it only months in advance, our options shrink to evacuation and disaster response. Let's sprinkle in some more asteroid facts and history. Did you know that Ceres, once classified as the largest asteroid, is now considered a dwarf planet? Or that Vesta is so bright it can sometimes be seen with the naked eye from Earth? The asteroid definition has even evolved over time, with some objects reclassified as dwarf planets or comets depending on their properties. These details matter because when scientists describe an asteroid hitting Earth, the exact consequences depend heavily on whether that asteroid is carbonaceous, silicate, or metallic. Speaking of composition, let's return to the question of what are asteroids made of. Many asteroids contain metals like nickel, cobalt, and platinum. In fact, entire companies are planning future asteroid mining missions, hoping to extract these valuable resources. Paradoxically, the same materials that could enrich humanity might also threaten us if they come crashing into our planet. Imagine a metallic asteroid 1 kilometer wide. The devastation would span continents, and yet not all impacts are catastrophic. There are countless craters around the world, like Meteor Crater in Arizona, formed by smaller asteroids. These serve as reminders of Earth's vulnerability. Every crater is a scar from a past asteroid hitting Earth. Now let's explore probabilities. Statistically, an extinction-level impact something like the Chicxulub asteroid only happens about once every 50 to 100 million years. A city destroyer, maybe a few hundred meters wide, might strike every 50,000 years. And smaller Chelyabinsk-sized objects hit every few decades. So while you don't need to lose sleep tonight about an asteroid slamming into your backyard, the threat is always lurking. But here is the good news. We are the first species in Earth's history to not only understand the danger but also to have the potential technology to stop it. Dinosaurs didn't have telescopes or rockets. We do. And that changes everything. Before we wrap up, let's revisit some essential asteroid facts from the asteroid. Definition: rocky bodies orbiting the Sun, smaller than planets. The asteroid belt, the main region between Mars and Jupiter where millions of them reside. Famous asteroid names include Ceres, Vesta, and Eros. Key question: what are asteroids made of? Answer: carbonaceous, silicate, or metallic materials. And the most critical phrase: asteroid hitting Earth a real risk, though rare, that science is actively preparing to prevent. Imagine for a moment that humanity sees a giant asteroid approaching with a 90% chance of collision in 30 years. The news spreads worldwide. Governments unite in a way never seen before. Billions of dollars are poured into spacecraft construction. For the first time, the survival of the entire planet depends on our engineering. It's both terrifying and inspiring. Would we succeed? Science suggests yes, if we act early enough. So the next time you look up at the night sky and see a shooting star, remember, it's just a tiny fragment, harmless and beautiful. But out there in the asteroid belt, millions of larger bodies roam. Each has its own story, its own orbit, its own name, and while most will never trouble us, the possibility of an asteroid hitting Earth is a reminder of how fragile and precious our world really is. Thank you for joining this cosmic journey. If If you enjoyed learning about asteroids, the asteroid belt, asteroid facts, and the science of what they're made of, make sure to subscribe to Space Exploration Technology, because the universe is vast, mysterious, and sometimes dangerous, but together, through science, we can understand it and even protect ourselves from it.